Okay, welcome back everyone. In this video we're going to take a couple minutes to look in more detail at a lot of the electrostatic quantities that we've been studying the past couple of chapters. And I find that there's often some confusion about how to use the different quantities, what relationships they have to each other, and so you could consider this video as one way to kind of review this. So I'm just going to start by drawing a little concept map that kind of links all these things together, and we'll start with the electric force, which is let's just use K instead of the 4 pi epsilon naught, but KQQ over r squared, and that is a vector. And then over here let's put the electric field. And so the electric field is just KQ over r squared. So one thing to point out is that these are both vectors, and there's some pretty common links between them. For example, we know that to take a force and turn it into a field, we have to divide by our test charge, a little q. And similarly, we know that if we take the magnitude of the electric field and multiply it by a test charge, now all of a sudden that gets us back to the electric force. So that's not anything too surprising. Okay, well now let's add in down here the electric potential energy, which we'll just say is negative K QQ over R. And one thing that we know is that force is the negative derivative of potential energy with respect to R. And so you see how force and potential energy are related as far as electric quantities are concerned. And we also remember that in order to find work or potential energy, we take the integral of f dr, and that gives us potential energy. Just a reminder that work is negative change in potential energy. Okay, so we've got that, and then finally let's put in voltage or electric potential. We know that this is KQ over R with a negative sign up there. And similarly, we know that to get from electric field to voltage, we just take the integral of field dr. And we also know that to get from voltage to field, we take a derivative. And just keep in mind that just like force and field are related by a test charge Q, so are potential energy and voltage. So if I multiply electric potential, or voltage that is, by Q, I'm going to get potential energy. And likewise, if I take the potential energy and divide by test charge, I get my electric potential, which is my potential energy per unit test charge. So I guess what I've done here is just kind of filled in some of the relationships that connect these four quantities together. And now we see also that these two, potential energy and voltage, they're scalars. So one way that we can kind of organize our thoughts is to think about how the two vector quantities are related and how the two scalar quantities are related. And also, if you want to get back and forth between vectors and scalars, you have to do a calculus thing, whether it's a derivative or integral. And if you want to go just from a vector to another vector, we're multiplying or dividing by a constant. In this case, the test charge, little q. Okay, so hopefully this was another way to look at things, and oops, I forgot an arrow going this way. And I will see you next time where we'll look at capacitors in more detail.